This is a Pi topic on ALEKS that asks you to find the inverse function of f and then also find the domain and range of the inverse function in interval notation. So let's first find with f of x, let's go ahead and find out what its domain is. Okay, so f of x is 5x minus 4 over 3x plus 2. So its domain, when we do that, we're looking at it's either all real numbers or you have some kind of a limitation or constraint on your domain. Well, whenever we have a fraction, we cannot divide by 0. So with fractions, we have this denominator, it can't be 0, so that's going to give us a restriction on x. So we just want to solve for that restriction. So I'm subtracting 2, dividing by 3, and I get x cannot equal negative 2/3. So that means on a number line, it can be anything to the left of negative 2/3 to negative infinity, anything to the right, but there's a problem at that point. So you actually have two different intervals. You have negative infinity to negative 2/3 union negative 2/3 to positive infinity. And we use the parentheses on the endpoint because it's an undefined value. All right, so that's the domain of the function. Now let's find what is the inverse of f of x. So remember that f of x really represents the letter y, and our first step to develop its inverse is we're going to switch all of the letters around. So I get x equals 5y minus 4 over 3y plus 2. Now I'm going to solve for y. When you have a fraction, the first thing you need to do is undo the division. So I need to multiply both sides by the denominator 3y plus 2. So that cancels the denominator out over here. And here I have x times 3y plus 2 is equal to 5y minus 4. Now you're going to clear parentheses and distribute the letter x to your terms. So you get 3xy plus 2 times x, or 2x, equals 5y minus 4. Since we're trying to solve for the letter y, I want to get all the terms that have a y on the left-hand side. So I need to subtract the 5y to the left. In the same step, I can take this 2x, since it doesn't have a y, and subtract it to the right. So I bring down 3xy, and the 5y is coming over, so minus 5y equals, bring down negative 4, and the 2x is being subtracted to that side. Now that I have my y's on the same side, I can factor out the common y. So you're just factoring it out from your terms here, and that gives you 3x minus 5. Okay, so the final step is to divide that group to the other side. And so you can stop here with your steps. That would be sufficient. So that right there is f inverse of x. So I get negative 4 minus 2x over 3x minus 5. And we want to do the domain and range of this. So the domain, you just calculate the same way we did with that original function. You take the denominator, 3x minus 5. You don't want it to be 0. So I'm going to add 5 and divide by 3. So x cannot equal 5/3. So the domain of this function is negative infinity to positive 5/3 union 5/3 to infinity. Now it also asks us to give the range. Now the range of the function is the same as the domain of f of x. So the range of the inverse function is equal to the domain of the original function. Okay, so my original function, its domain was negative infinity to negative 2/3 union negative 2/3 to infinity. So that's how you find the range. You just use the original domain. So when you have, your original function f of x and your new function f inverse of x, some properties are the ordered pairs. Like if you have 2, 3, then the inverse ordered pair would be 3, 2. So the coordinates of the original function get switched around for the inverse. Well, the domain and range also gets switched around. So you have your domain of f of x and your range. When you do your inverse, the domain is equal to the range, and the range is equal to, you get your final domain there. So the domain and range actually switch around as well, just like your ordered pairs would.